Low ceilings and restricted visibility are two elements of flight that affect all operations. Low ceilings may extend to the ground in the form of fog, while precipitation can restrict visibility to the point where navigation by ground reference is extremely difficult. Both of these elements are characteristic of warm front weather systems. Flying in areas dominated by warm frontal weather can be dangerous unless you learn to recognize and take into account the many flight problems involved. In order to do this, you must be familiar with the causes and effects of warm frontal weather systems. The atmosphere over the northern hemisphere consists of polar air masses over the northern portions and tropical air masses over the southern portions. A semi-permanent boundary or frontal zone exists between the air masses called the polar front. It is in reality a stationary front. This zone of discontinuity encircles the Earth near the 60-degree latitude. The front may remain motionless, or it may drift back and forth across a region for days, producing inclement flying conditions for a long period of time. The winds on both sides of the front are from opposite directions and parallel to the frontal line. A polar outbreak can cause this front to move to the south as a cold front. If the front stalls, it may again become a stationary front. Uneven local heating or terrain irregularities may cause small disturbances in the wind pattern and initiate a wave-like bend in the front. If this tendency persists, the wave will increase in size, setting in motion a general counterclockwise or cyclonic flow of wind. As the wave continues to grow, the wind in the tropical air can no longer flow parallel to the stationary front. The flow of warm air moves up over the cold air. Likewise, the cyclonic flow of cold air begins to wedge under the warm air. As the two movements continue, the frontal zone is no longer stationary. The eastern side of the wave becomes a warm front, as the warmer tropical air replaces the retreating polar air. Let's look at this warm front closely. Warm frontal passage is signified by a pressure fall, then rise, a wind shift from the southeast to southwest, and a rise in temperature. To be classified as a warm front, frontal passage on the surface must bring a rise in temperature. The prevailing westerly winds of the mid-latitudes and Coriolis force give a typical warm front a direction of movement to the northeast through the United States. The warm frontal line on the weather map represents the surface boundary of a retreating mass of cold air. Surface friction slows the movement of the retreating cold air near the ground. The faster-moving warm air aloft rides up over the cold air, causing the frontal slope to be long and shallow. The warm air is lifted as it flows up over the cold wedge of air. This causes clouds to form, usually in stratified layers. They will spread out over the mass of cold air and may extend for a distance of 600 miles or more in advance of the surface front. Precipitation falling from these clouds causes lower clouds to form in the cold air underneath. The low clouds cause low ceilings, and the precipitation restricts the visibility. These conditions may cover an area 300 miles or more in width. The cold air is very shallow for a distance of 50 to 100 miles in advance of the front. It is in this region that the low clouds generally lie on the Earth's surface, causing reduced ceilings and visibility due to prefrontal fog. Because the warm frontal clouds are usually in stratified layers, you can expect smooth flight through them. This is a warm front with moist, stable air. This front has a shallow slope of about 1 to 200. However, warm fronts with conditionally unstable moist air can spawn scattered thunderstorms. These thunderstorms are hidden from view in the warm front cloud system. This front has a steeper slope of about 150 or 100. Warm fronts, as a rule, have and are less violent than those associated with the cold front. But severe turbulence can still be encountered in them. They are a greater problem than those associated with the cold front because they are hidden by the other clouds. When you approach a warm front from the cold air side, you can recognize its presence by the order in which the clouds precede it. The first indication of a warm front ahead are the wispy cirrus clouds at a very high level. The cirrus clouds will be followed by a thin overcast of cirrostratus. The cirrostratus gives the sky a milky appearance and does not obscure the sun or the moon, but results in the appearance of a ring or halo. As you approach the front, you will observe a lower deck of clouds of the altostratus type. At first, the disk of the sun or the moon will be visible through the thin leading edge of this deck. And as the altostratus becomes thicker, the obscuration will become evident. You may encounter precipitation when you reach a point where the base of the altostratus is some 8 to 12,000 feet above the surface of the Earth. In this area, non-uniform clouds, usually of the stratocumulus type, will be present at various levels in the cold air. You are now entering an area where instrument flight will be necessary. Also at this point, the low clouds will lie close to the Earth's surface, resulting in low ceilings and restricted surface visibility. As you get closer to the front, the precipitation will become more steady, and all the cloud decks will become indefinite and merge with each other. If in this area you encounter intermittent heavy precipitation, it is a good indication that hidden thunderstorms are present. As you continue your flight, surface conditions become worse. The ceiling will get progressively lower and surface visibility more limited. For a distance of 50 to 100 miles, the ceiling and visibility will be near zero due to prefrontal fog. In this area, landings are often impossible due to zero-zero weather conditions. After you pass through the frontal system, the upper clouds will disappear. Weather conditions behind the warm front will vary with the characteristics of the warm air mass. Low ceilings and restricted visibilities in the warm air are common in the middle and high latitudes over the open sea during all seasons of the year, and over continental areas in the winter months. This low cloud deck may extend for many miles out into the warm air. It may exist as postfrontal fog, when there is a very moist area behind the front. When surface winds are strong enough to prevent fog formation, stratus clouds will be present. Stratocumulus clouds will form when there is turbulent mixing due to strong surface winds. Whenever you make a flight into warm frontal conditions, careful consideration should be given to pre-flight planning. Ice accumulation on your aircraft constitutes a serious warm front hazard, especially during winter months. During this season of the year, the temperatures in both the cold air and the warm air are very important to you because icing conditions are governed by the temperature. In a typical winter warm frontal situation, the temperatures of the cold air are generally below freezing. The temperatures of the warm air sector in the lower few thousand feet are above freezing, while temperatures at higher levels are below freezing. The clouds that exist in the warm air under these conditions contain moisture in various forms. Generally, they range from ice crystals at high levels in the clouds, where the temperatures are well below freezing, to water droplets at lower levels, where the temperatures are above freezing. In the band where the temperatures are between 0 and minus 18 degrees centigrade, the clouds are composed of a mixture of ice particles and supercooled water droplets. Because of the presence of water in liquid form and below freezing temperatures, you may expect icing conditions. In the area where the temperatures are below minus 18 degrees centigrade, the clouds are composed mostly of ice crystals, and normally formation of ice will be encountered. It is always wise to anticipate icing whenever the temperature is 0 degrees centigrade or below, and there is a visible form of moisture in the air. In the lower portions of the clouds in the warm air sector, where the temperatures are above 0 degrees centigrade, no icing will be encountered. Under this area, where the temperature of the warm air is above freezing, rain will fall. When the temperature of the cold air is below freezing, the supercooled raindrops will freeze as they contact an aircraft. This type of precipitation is called freezing rain. Under the area where the temperature of the warmer air is below freezing, dry snow will fall. Between the dry snow and the freezing rain is a relatively narrow transitional zone. In the upper portion of this zone, there is a mixture of rain and wet snow. As this mixture falls, it will freeze and become sleet after transiting the considerable depth of cold air. The precipitation zone under the warm front may be divided into two areas. In one area, freezing rain and wet snow are falling through sub-freezing temperatures. Ice will accumulate rapidly in this region, presenting a very severe icing problem. In the other area, dry snow and sleet are falling. There are two areas where ice formation is most dangerous. In the cold air, where the precipitation is in the form of freezing rain or wet snow, and in the clouds, where the temperatures are between 0 degrees and about minus 18 degrees centigrade. Warm fronts have seasonal variation, but can affect flight operations over hundreds of miles. They move slower than cold fronts and signal their arrival through easily distinguished clouds. The associated weather may include 0-0 conditions and severe icing in clouds or freezing rain. When warm fronts mix with cold fronts in frontal waves or occlusions, the result is a combination of cold and warm frontal weather. For maximum safety of flight, you must understand the characteristics of warm fronts to minimize your exposure to their severe weather.